Okay, let's start on time. So, welcome to Passover Networking Research Group. Brian, unfortunately, is not with us today because he had to make a hard choice between this session and his vacation. And as you can see, he made the right choice. So that's going to be interesting because I'm going to do it single-handed. Let's see how good I am at multitasking, which probably means I might miss something in the chat room. So please let me know if I'm missing anything important. So, note well, I hope it's the right one. I'm quite sure we've seen it before. You've seen it before. I'm not going to read it out loud. So if it's the first time you see this slide, please look at the meeting materials and the agenda and make yourself familiar. It's all being recorded, including the chat, by the way, so think twice before making jokes there. Housekeeping. First of all, please, unless it's your turn in the queue or you're presenting, keep your audio and video turned off. If you want to comment, raise your hand, wait for your turn, and then send audio or video. It would be really nice if you don't forget to leave the queue. It would prevent some confusion on my side. I guess we've all learned it because it's already Thursday or Friday for me, that if you cannot hear me, it probably means you should turn off your VPN. I don't want to expect you to say your name out loud and affiliation as well, because in most cases we can see who is speaking, but it still might be a good idea. Dear speakers, I hope we all gonna use this share preloaded slide presentation so you can control it. Let me know if you want me to advance slides for you. The biggest problem we have right now, so we cannot proceed, is that we need a minutes taker, and as we now going to call it, Jabber medium, someone who will convey the messages from the chat room and make sure that I am not missing them. Please, we need volunteers. Thank you, Teresa, for being our medium. We still need a minutes taker. Come on, I know it's a hard job, but I cannot do everything. Not today. We need a new feature in MeetEcho, right? When a random participant is selected, is volunteered as a minutes taker. Come on, we have 65 people. Out of those 64, someone definitely could take minutes. We cannot proceed as far as I know if we don't have minutes taker. I cannot ever bribe you by offering a drink. Not on the virtual meetings.
This is Spence. I can do that, but it would be extremely good if somebody was over there at least checking my work. And of course, anybody can be in the COVIDMD document. Anyway. So anyway, I'll see if I can get started, and please do corrections even if you're not able to type.
Thank you, Spencer and Tom, for helping. Yeah, I guess, Tom, your help will be needed when Spencer is presenting particularly. Thank you very much. So we have a full agenda. So let's try to be on time. And before we proceed, what's going on in the group? First of all, congratulations, everyone, and Spencer in particular, for publishing our first RFC of obstacles to deployment. Great job. I'm really happy to see it happening. Surprisingly, it was published before the question draft. Question draft is currently in the IRSG poll. So hopefully we'll see it as published document as well soon. And we have one active research group document, which will be actually the next presentation. So, Cyril, the floor is yours.
Okay, can you hear me?
Yes, I guess I shall share slide. Okay.
Request.
Grant Brill. Yes, I think it's what I'm doing the right thing now. Can we?
I think that should work.
Yes, okay. I can see your slides now.
Okay, perfect. So yeah, let me get started. So today I'll present the new revision that we did on the vocabulary of path properties draft. I think it will probably not take 10 minutes. So since you have full agenda, I guess that's a good thing. Yeah, so first of all, thanks for all the participation in the mailing list and for the good feedback. So one of the main things we did is we revised our transparency property. So the transparency property is now defined as follows. If a node performs an action on a flow transparently with respect to some meta information, if it performs the action independently of this given meta information. So this transparency property is defined on a flow with respect to an action. This transparency property is defined on a node with respect to an action, a flow, and some meta information. And we defined some examples of actions, but this list is non-exhaustive. So actions can be blocking packets, modifying either packet headers or packet payloads, or forwarding packets on specific outgoing interfaces, for example. And then the meta information can, for example, be the existence or the content of the different protocol headers and also of the payloads. So the main difference to the last revision is that we more clearly defined this item. So we more clearly defined the actions and the informations, and we defined them on a flow instead of on a packet as it was before. To give you some examples, here we have this table with 3 columns. The left column shows a type of node, and in the middle and right column we can see whether this node is transparent to transport layer headers, so for example TCP and UDP headers, and whether it's transparent to IP headers. So first you have a very simple IP router which decides where to forward the packet based on the IP header, so based on destination IP address. However, it does not even need to look at the TCP and UDP headers, so it's transparent to them. However, it's not transparent to the IP headers. And then we have kind of the opposite, which is a very simple firewall rule, which simply blocks incoming TCP SYN packets. So such a node would be actually transparent to IP header since it does not even look at the information in the IP header to decide whether to block. However, it will not be transparent to the TCP and UDP header contents since it performs the action blocking based on the content in these headers. And then we have a network address translation node, which is neither transparent to the transport layer headers nor to the IP headers, since it might block packets, it might forward them to different outgoing interfaces, and it might even modify the port or IP addresses, port numbers or IP addresses. And then so the term transparency is also used in other IETF draft, and this sparked some confusion. So we added a note which says, for example, a transparent HTTP proxy, which modifies some mutable fields in the HTTP header, would not be considered transparent given this definition. And in the same way, in the transport protocol path signals RFC, a node reacting to either implicit or explicit path signals would also not be considered transparent. However, the way we define this transparency property is that it's easily extendable, so that you could, for example, define a specific action for HTTP proxy, which says only modify immutable HTTP fields. And then you could still define transparency in this way, but we do not want to try to come up with all possible transparency examples. So we try to give some intuition and then make this definition extendable. The second big change since the last revision is that we added a formal definition of the term entity. So we actually already had this term and we used it, but we didn't give a formal definition, which was slightly confusing. So now we defined an entity as kind of the most basic term in our document. So an entity can be a physical device or a virtual device, or just a function applied over a set of packets. It can be an on-path entity, so basically a node, or it can be off-path, and it can be in the data plane or in the control plane, for example, a CDN controller, SDN controller. An entity can process packet, it can measure path properties, and it could also access information gathered about specific paths. And basically every node is an entity. However, not every entity is a node. So as I said before, an SDN controller may be off path and does not be a node. These are the two main changes. So if you have any thoughts on this transparency definition or the new entity definition, please comment here or on the mailing list later. And one other item was, do you think this document is ready for last call, or are there still big issues that need to be resolved? So that's it for the presentation. Please ask questions.
Yeah, questions? Anyone on the queue? Okay, Sabine, please. Please go ahead, Sabine.
Okay, can you hear me?
Yes.
Can you get back on the previous slide, please, regarding the entity? Well, I would figure out an entity as being some part characterized with respect to the fact that it is some part in the network, but also you also characterize it with respect to some actions. So do you? So it seems that there may be like several parameters that characterize an entity and that characterize the fact that it is an entity. For example, here in your bullets, I would figure the one of the parameters would be what it is, what animal in the network it is, part of a path, a device, or a functionality, and also a role. Do you have such characteristics for entities?
We don't have these characteristics right now. So the way we use entity in this document is to describe, as you said, something in the network, essentially anything in the network. And then if we want to be more specific, we have a lot of terms. For example, a node, which is on path, a host, which is generally at the end, a link, which connects two nodes. So we have all these terms building on top of an entity. That's why an entity is kind of the anything term. But we didn't clearly define it before, so we just tried to use this anything term to then define further more useful terms.
And then just a quick question. So do you foresee to specify a set of parameters that would characterize an entity, and also a set of parameters that would characterize the fact that it is an entity?
Yes, we do it by like kind of this inheritance style, right? But to define it for the entity itself might also be interesting to look at. I will need to think about it. Which of these classification would make sense or would be useful to have in our terminology? But I think there might be merit to already kind of classifying the entity definition, so specializing it.
Okay, thank you.
Okay, so we have 30 seconds, so one last question and I'll close the queue. Robert.
Can I ask a question?
Yeah, sure, sorry. Yeah, after you close the queue, yeah. Go on.
Okay, I'm Richard. So 2 questions. Number 1, I like that you mentioned the entity somehow should be in the context of inheritance. For example, when I look at, of course, I'm new. I look at entity, I would map it to a concept like, for example, the object class in Java. But the reason why you introduce object class is essentially serve as some kind of root object is you want to introduce all kinds of functions, right? Clone, equals, finalize, and you put a bunch of objects into it. So therefore you do wait, notify. So what exactly some functions you envision, some very common functions you envision would exist across all kind of entities? Do you have even some kind of very concrete functions you have in mind? Am I lost? Hello?
No, we
Caroline
can hear
speaks.
you, but Cyril's audio seems to be off. So if I may jump in as the other author of this draft.
Okay, sure, Teresa.
Yeah, sure. So as we said, we don't have like a formal classification of entities or properties of entities, but we do already mention different entities in our use cases section, right? We talk about path selection, and there could be an entity on the path doing the path selection. There could also be an entity off the path to do path selection. And so I guess that would be a starting point if we are going to have more.
Yeah, because the main reason you introduce entity is something like you in OOP, you introduce the root object. Essentially, you're doing some kind of like a refactoring, and you want to extract some common properties. For example, in this context, I would imagine you want to have some kind of common ID. Every entity would have a common ID somehow. Then it makes sense. But otherwise, if you have term, but without any like binding properties, it sounds a little bit too abstract. And therefore, somehow, oftentimes this type of like root object should be somehow deleted from the class hierarchy.
Okay. Yeah, I will think about that.
Okay. So the second very quick question. Can I ask second question? Or I can
Quickly, very quickly.
Okay. So second question would be, what's the purpose of defining transparency and what kind of accuracy do you want? For example, and I took a very quick look at your definition of transparency. I will look at essentially define, it can be defined in a very precise way of using a mathematical expression. Basically, you define that it's transparent to a field. Basically means you're transparent to a set, and you always get the same value, right? And you always get the same value. Would that be considered as transparent? Or so what exactly, or can be maybe, for example, if I have a firewall or net, I would always, no matter what it is, I would always output the same value. Would that be transparent?
Yes, I think.
I even shouldn't even read, for example, I'm sorry, let me clarify. There are 2 ways in program language design. One way is, no matter what I do, I return constant. Second one is, even from my tint analysis, I should not even look at your code. If I look at it, I'm tinted, so therefore I'm not transparent. So which one you're trying to go? Go ahead.
Robert, may I suggest, like, Cyril, give a quick answer, and I think we should take the rest of it to the list because we are like out of time. Sorry.
Yeah. To be honest, I don't have an exact number. Maybe let's discuss it on the mailing list and continue.
Cool. Thank you. So Spencer, you are next with another path topic, path selection. Okay.
Okay, Jen?
Yeah, do you want to use the preloaded slides, or you want me to?
Is it okay if you do the slides?
I do the slides. Okay, yeah, I can do the slides.
Okay, great.
Okay, sorry, share. Okay, looks good?
Yes, thank you. So this is talking about something that I've been talking about in the IETF for a while, and probably needs to be talked about in the IRTF more than it needs to be talked about in the IETF. This is talking about path selection when you've got multiple paths at a pretty high level. So stepping back, next slide, please. So we've had multipath transport protocols in TSV for a while. We've had them for TCP. We've had them for SCTP. We're starting to start an adoption call for DCCP multipath in TSV working group as of this morning, and we've been talking about that for Quick. Never mind. So there are a bunch of interesting technical questions like multipath sequencing and loss detection and congestion control and reordering and stuff like that. But there's a less technical question I wanted to focus on, which is what are applications actually trying to do? There have been a lot of use cases put forward in discussions, especially in the Quick Working Group, and not a lot of commonality between use cases. So I wanted to step back and ask how many path selection strategies are enough? I got this question from Christian Wiedema on a previous document. Next slide, please. So here's what I've seen so far, and these links are actually active if people have curiosities in the slide deck that's in the proceedings. But there are at least 10 path selection strategies that were described in discussions in the Quick Working Group so far. That's been the most active place for talking about use cases that I'm aware of. The number of desired strategies is growing over time, and it's not obvious to me that there's an upper bound on the number of strategies. There is a children's fairy tale about Goldilocks and the Three Bears, and the punchline for that was something is too big or it's too small or is it ever just right? And that's kind of how I feel about the path selection strategies. Just using three that are described in more detail in the draft, you could have, I want to go for the path with the lowest RTT, or I want to go for the path with any path that has a RTT below a certain threshold, or I want to use all the paths that have roughly an equivalent RTT. Those are really close together, and that's interesting. And the other thing that's gotten really ugly in discussions is that the arbitrary combinations of path selection strategies is not just possible, it's already happening. It's happening in IETF and in 3GPP, which is another place that a lot of this stuff has been talked about. And next slide, please. So and like I said, these are all live links if you look more closely, just because we don't have unlimited time here. But my question was, rather than continue to ask path selection strategies, can we identify building blocks and use them to support new strategies? And the thing I wanted to focus on here is that there was another strategy that was described in an ARW paper earlier this week. So selecting the cheapest path. So that's not any of these, but anyway. So next slide, please. So what I'd like to do is to assume that multiple active paths is going to become more realistic over time. Not just use Wi-Fi when you got Wi-Fi and 5G when you don't. Even in 3GPP right now, there is the concept of having 5 5G or 4G or public Wi-Fi in a couple of different variations, or private Wi-Fi, and we could talk about that. So the definition of the goal for path splitting would be beyond utilizing all available bandwidth across two paths, which is kind of where we are right now. What I'd like to do is trim down the strategies as much as possible. I think we could eliminate maybe a couple of them just based on how similar they are, but they're not the same. But and whether like latency versus bandwidth is a strategy, but no one chooses high latency. But I want to, more than that, identify building blocks to assemble and support new strategies. So next slide, please. So here's why I'd like to do that. There's some implementers that really can handle multipath just fine today, either doing granular control, which we can talk about in more detail. Certainly the nice people at Apple have talked about that in more detail. Or bandwidth aggregation, which was a common use, which was a common conversation in 3GPP and in places like the Broadband Forum and stuff like that. Either granular control or bandwidth aggregation, like I said, great. I think we're really at the beginning of making multipath broadly usable. I'd like to make it easier to use for applications. Kind of basically saying, well, if multiple paths are available, why wouldn't you use them? But using multiple paths means different things for different use cases. I'd like to support multicast without requiring constant library upgrades. Questions like, how many selection strategies do you put in a library? How many libraries do you ship with a application? And at least some strategies get standardized, so there's more maintenance work as they get added with no upper bound. Next slide. So these are the things I'm hoping that we will talk about. And the first one is this research? I actually was kind of pleased to hear Martin Duke say earlier today that he thought a lot of the high-level discussion about multipath really was research and not engineering. So I'm feeling like at least somebody agrees that might be a good place, that Panrg or someplace like it would be a good place to have that conversation. I'd like to find out if it's interesting to anybody. And I'd like to find out if people think it's doable. And of course, do you want to help? We can talk here, and we got about 7.5 minutes to talk. And we can talk about it together, and we can talk on the mailing list, and we can talk on GitHub. There's actually, if you look at my draft, there's actually a GitHub repo that accepts issues and things like that also. That was, I believe, my last slide. No. Please go to my last slide and then come back to this one. Thank you all. Please make good choices. Now let's go back.
Okay, cool. Teresa.
I liked your draft. I read it. It's interesting. It fits well in this group, I would say, and I am willing to help by reviewing, for example.
Thank you. Tom, you're taking notes right now, and please make sure you get Teresa's name if you don't get anybody else's name.
They don't worry.
Next.
So I did read it very quickly. This is Richard. And I found the problem to be very interesting. But I also want to see that actually it can be very hard. Depends on what kind of outcome you want. For example, I'm going to send you a link, which I have a paper. I think it's SIGCOMM 2018. In that paper, it's called Trident. And if you look at table 1 of that paper, it's SIGCOMM 2018 called the Trident paper. We have something called the route algebra. Basically means that one we call route. We don't call it path, but somehow you can think about the route, somehow very similar to a path in some sense. Okay. And we tried very hard to come up with something called route algebra. If you read it, essentially we define around like 8, 9 operators. Therefore, every single operation, like all the strategy you mentioned, can be somehow composed using this something called algebra. But then I still remember, let's say 3 years ago, and all the CCOM reviewers like, why is this framework complete, and why this is optimal? All kinds of things which I don't know how to answer. So I think you are trying to somehow coming up because you want to talk about all the 10 strategies. Do you have some kind of algebra to essentially to be minimal,
Yes.
to be complete,
Yes.
all kind of properties? And I can send the link, and of course, we can of course talk offline.
Could I ask you to send the link to the Panrg mailing list, and we'll make sure that it gets into the minutes also.
Sure.
I appreciate that a lot, and that's exactly the kind of thing I'm hoping for. The other thing that I didn't, because we have a short period of time to talk about, was that not all these strategies are at the same level.
Sure.
Some of them are pretty high level. Some of them are at the level of especially once you start combining things to say, well, I have 3 paths, so that's like load balancing. But when one of them goes away, I want to fail over to the 2 paths that still work. So that's like something else. So. Like I say, I look forward to seeing the paper, and I look forward to continued discussions in Panrg. Cool. Anybody else?
Perfect. Thank you. I think we're getting back on track time-wise, which is just fantastic. Okay,
there's no way that Brian will ever believe that I stopped talking early. So tell him what a good job you're doing.
We have a video proof of this, and by the way, I do prefer people to have communication about this on the mailing list, or maybe on GitHub and mailing lists. At least important things, please keep them in the mailing list as well, even if you discuss them offline somewhere. Okay, let me stop sharing slides. Tom, you are next. Okay, are you going to? Yeah, okay. Let me grant you permissions.
I've never used these buttons before.
New shiny thing. Should work. Okay, let me stop this one. Okay. I'm gonna start a timer for you.
Awesome. Hi, I'm Tom Jones. I'm a researcher at the University of Aberdeen. We have written this draft. We've called it Transport for Satellite. We think with TSVWG prefix there might be temporary, but we will see. We've written this document because there's been work in the IETF on satellite systems in the past, and there's increased interest now. But the most contemporary work on transport protocols and satellite came out of the TCP-SAT working group that concluded in 2000. TCP-SAT produced 2 documents, 2488 and 2760. And 2488 did a really good job of describing the physical characteristics that limit geostationary satellite communication, and it suggested some improvements. And 2760 followed up with TCP changes, which were experimental at the time, that really helped the protocol communicate better when used in a geostationary satellite situation. If you look at these now, they're out of date in respect to TCP, and the numbers, other than the physical constants, are sort of out of date as well to what satellite services have. So satellite services today are much faster. Sadly, TCP over satellite, the speed comes from PEPs rather than the protocol itself. And so we have the situation where PEPs are sort of a key component to geo communication, and PEPs are also a deployment barrier for other protocols. And so PEPs make it hard to deploy TCP modifications over time. They drop a lot of support for things. They make the satellite component of the path invisible actually to a lot of networks. And they're now impossible with QUIC because the split TCP model of operation is gone with encrypted authenticated transport. And now we're starting to see a wider range of SATCOM systems come into view. So we're seeing larger deployments of LEO systems, and we're seeing deployments of MEO systems. And so we tried to write this document to try and capture some of this. We think that satellite systems require path awareness. I think you could reasonably say that the PEP, so the performance enhancing proxy in a satellite system, is path aware. It knows what is happening inside the network, and it knows it has this long delay, and that is part of why it is able to accelerate connections so well. And we have satellite topologies in all sorts of different forms as well. So we're not just talking about internet looking paths that look like broadband internet. We see big distribution networks where we have point-to-point links where we're pushing out video. We see transit networks, and we're starting to talk about almost delay tolerant networking style, like blob networks that we can use with the satellite. And so we have this network component that has many different views to it, and it is becoming part of an end-to-end path. And user traffic gets to experience the interesting components of satellite as well. And so satellite capacity, we have long variable delays, and we have wide range of access technologies. And so this can make it a bit hard. So we've written this draft. The draft originally started as advice for Quick because there was a lot of concern in the geo market that Quick was just not really going to work very well. Early results showed that Quick was reasonably competitive compared to TCP with a PEP. So Quick actually got a nice feather in its cap. And so I'm just rushing up to try and finish so we can talk. And so we've laid out the document in a way following from 2480. So the document originally came from Quick, and it was very Quick-centric. But I came and joined the author team, and I thought maybe we'd better try and offer generalized advice to the designer of transport protocols and how the considerations of satellite networks lead onto these. And so we have a new format where we talk about the different types of networks and then how these networks mitigate the complexities of satellite networks. And then we hope to talk more in detail about different protocols. And so we are going to find it really easy to get TCP-specific mechanisms for geo, and maybe a bit harder to get more mechanisms for other places. So there is ongoing work to look at Quick. And so for Panrg, we have a couple of questions for you. We think this is great, and we think this is a sort of a core area where path awareness is required, and we need to design around this. And we'd really like to generate advice for transport protocol authors. We'd like there to be a document to point at in the future, so you can say that this is why you need to be able to deal with like long RTTs, or this is why you need to deal with massive spikes in latency. We need input from people that operate LEO and MEO networks. Operators, users, people reselling the networks would really appreciate input because we're sort of lacking in information here. And then for Panrg, we wonder if this is work that is of interest to Panrg. We think it might be because the path component is so core. And we'd love to hear people's thoughts on how we should move forward with the draft. Spencer.
Okay. Yeah. And after Gore, I'll close the line because we have about 4 minutes for people in the queue.
So I just wanted, this is Spence. I just wanted to say that thank you for bringing this work here, and the generalization that you're talking about and the focus on advice to transport protocol designers. That's the way that the PILC working group went with wanting, basically, if you look at the output of the concluded PILC working group, there's a RFC number, which I don't remember what the RFC number is, but it's advice to sub-network designers. That's again very generalized. So what you're talking about is very consistent with what we've done in the past that worked well. Thank you.
If you could follow up with the RFC, Spencer, that'd be really nice.
Okay, Hesham, you next.
So have you done work on the convergence of terrestrial networks and satellite networks? How to converge the two?
Are you talking about handover, where you might have redundant links? Is that the sort of situation you're talking about?
That's one idea. The other one is, instead of using links between satellites, we can use links on terrestrial networks.
Yeah, and so we do have a section talking. We have a section left open for hybrid deployments, but what we need is information about real networks and ideally networks that we can experiment inside of. And that would help us characterize the network so that we can create advice for the designers of transport protocols. And so we are happy to consider a variety of different networks, though particularly we're focused on SATCOM and this sort of LEO, GEO, MEO deployments, and networks that we can play with, we'd love to play with.
So what forum you mentioned? You said you have a forum about hybrid networks.
So in the document right now, we've left a section open so we can talk about hybrid networks. Right now, discussion for this is happening on the E2SAT IETF mailing list. And I'll pull up that and put in a note in the minutes after I stop speaking.
That would be good. Thank you.
Teresa.
Yeah, quick comment. So I read your draft. I liked it. I think it's it fits well into Panrg as well because it's a specific example of path awareness, like you list path properties that some entity is aware of, I would say, and then you optimize. So I would say maybe it's not just advice to protocol designers, it could also be some protocol configuration, right? So your path aware entity could say, oh, maybe Quick should use a specific algorithm because it's on a satellite network, or maybe your TCP parameters could be in some way because it's on a satellite network. And so maybe that would fit in there as well. I'm not sure.
Yeah, thanks, Teresa. That's really helpful. So for TCP, we have a hard experience with this because you have to tune buffers to make TCP go fast when you don't have a PEP. And so specifics for TCP and Quick could actually be quite interesting to include in the document, if not in an appendix, so that at least that information is captured. Thanks.
Gore. We can't hear you if you're speaking. Gore? Okay, looks like we have some audio issue. Or maybe he's just speechless. So excited.
He's just so happy.
Yeah, nothing to add here, right, Gore? Okay, so I don't know, Gore, where you can put your questions in the chat or in the mailing list. So, Tom, I suggest you forward the draft to the mailing list, right? And we can continue discussions there.
Okay, thanks, Jen.
Yeah, cool. Okay, thank you. So, Juan, are you next? Let me grab the slides. Okay. And okay, I'll start timer.
Hi, do you hear me well?
Yes, we do hear you loud and clear. New desk
right.
being shared. I still do not see it happening for some reason.
I don't see the slides here.
Yeah, that's interesting.
There we go.
Can we try?
Yes,
I
got
okay,
it.
so
I got
just
it.
slow.
I got it.
Okay.
Yes. All right. You see the slides, don't you?
Mm-hmm.
All right. Thank you very much. Jen.
Go on.
So I wanted to talk about the lightning filter, which is a product that we have developed as a showcase for DRKey. The particular thing with this filter is that it's high speed and it's quite inexpensive. So I think it could be interesting for developing later DRKey and also to start a discussion. Maybe people will find out that this is an interesting thing to talk about. All right. So this is the index. I just left it here for anybody later to take a look at the slides. Maybe the high-level characteristics of the filter is that, of course, it's based on DRKey, and that makes it suitable for high-speed connections, which at the moment is running with 4 times 4 gigabits a second Ethernet cards, running actually in a normal PC, quite inexpensive, as I was saying before. The thing is that every packet is source authenticated cryptographically, and that the speed of the filter doesn't depend on the number of flows or senders, actually also not, of course, on the number of paths, but only on the number of packets that are transiting that filter. I'm going to be using this scenario, this deployment scenario for the presentation. This is the science DMZ, in which on the right-hand side, on top of the slide, we can see this kind of computing cluster that is accessible from a set of clients that is predefined at the beginning, and nobody else is able to access them. Traditionally, there will be a normal firewall, so a traditional firewall over there, but the problem is that they are typically quite expensive if we wanted to run 200 or 200 gigabits a second, and thus the deployment that we have done in this scenario is replacing that firewall with a lightning filter. Some of the different deployments, we collocate the filter with a traditional firewall, but in this one would be just replacing the firewall completely. So the basic architecture for the filter is, well, the data plane, we'll see that in the next slide, but it's just the filters themselves is a modular design, and then we just rearrange the pipeline as we find suit. The control plane is there just to support the data plane, of course, and in the presentation, I'm just going to be talking about the fetching of the DR keys themselves, because the other parts are just quite standard. All right, so this is the pipeline of the filter itself. On the left, we have the entry or the entry point of a new packet arriving. We just have the top of the pipeline taking care of the regular IP and this forwarding to the traditional firewall. Then we have that distinction between IP and SIAN, which is just a path-aware architecture running with DR key. And then if that's the case, we just do the normal work for the filter, then check that the destination is not saturated. We can configure a rate limit for that destination. If that is the case, we just drop the packet, otherwise we continue, and we do the check of the source authentication for that packet. I'm going to be talking about that one in particular. Then if that is correct, then we go on and we check for duplicates. If that is not a duplicate, we would forward it to the computational cluster in that case. All right. So DR key is kind of necessary in this product, in this filter, because otherwise we wouldn't be able to process at that speed, isn't it? So that we need to process packets in nanoseconds, really, even with because we want to run it in a, like we said, in a normal PC, and then that would be impossible to be to derive keys using, for instance, asymmetric cryptography. We have to use this kind of different techniques. Also, because we can source authenticate each one of the packets, we are going to prevent source spoofing, source address spoofing, and also it makes sense now to do a duplicate suppression, a duplicate detection, because now it's not trivial to have a different packet. So we can, for instance, use Bloom filters to detect duplicates easily. And just for anybody that would be interested in this, in the DR key terminology, slow path is the client or the different clients that we have sending data to the filter or to the computational cluster, and the fast path is the filter itself. So that is where the filter lives. All right, just as a quick reminder, I think I still have some 2 minutes left. The communication in DR key is about, the procedure is about exchanging the keys and then deriving keys later from that keys that we have exchanged. So we have 3 different levels, 0, 1, and 2. Level 0 is just the secret. There's never leaving the AES itself, and it has tied or bound a validity period. Then we have level 1, which is just the keys used to communicate between pairs of AESs, always with a fast and slow side for the derivation. And then we have the level 2 key, which is the actual key that we use to compute the MAC of each one of the packets. That key in particular, level 2 key, is going to be derived live every time that we see a packet, but that's derived in nanoseconds. It's faster than an actual memory lookup. This is going to be interesting also for what we want to do later, which will be introducing authentication of each one of the steps that we have taken along a path. and thus path validation and authentication, whether we have traversed that path or not. That's the reason that we also want to take a look at DR key for path-aware networks. In this slide, we're just seeing an exchange of an L1 key, which is just a regular thing that we do in the control plane, meaning that we do that ahead of time, typically like 2 periods ahead of time or 1.5 periods ahead of time. So in this case, we have just one AES with some clients over there, and then the AES-B is where our filter lives. And since we have that scenario configured, we know that we have to retrieve the L1, so the level 1 key from the AES-A. We do that with every AES where we have clients configured. In this mode of operation, we have to retrieve the L1s. If we wouldn't know the different source AESs, we would have to choose a different configuration for DR key, in which we actually share a bound to protocol level 0 key instead of a level 1 key. So I think that was the end of the presentation. I would love to have some questions about either the feasibility of some scenarios or DR key itself. Thank you very much.
Okay, so, oh God, I can't get back to the, so do we have anyone in the queue? Sorry, my browser is misbehaving now. So, no one? Okay, so
All right, thank you.
Juan, maybe you can send it here to the mailing list. And unfortunately, I found the list being rather quiet recently. So maybe
Yeah.
you can send it and bring some live there. Yeah, anyway, we just have 1 minute. So maybe people have comments, but they are so substantial they don't want.
Of course, the mailing list would be a great forum to ask
Yeah,
questions
yeah.
about this.
So please do.
Thank you.
Okay, and last but not least, Tommy, gonna tell us about path-aware routing.
Oh, all right.
Okay.
Should I do the document sharing thing?
Yeah, grunting. All yours.
Boom. All righty. Hello, everyone. I'm sorry, I was just coming over from the IAB open meeting, so I apologize that I missed all the other lovely presentations earlier. But thanks for giving me this little bit of time. So I wanted to share some thoughts about kind of path-aware routing based on some work that we're currently doing in deployment for deploying some mask proxies. And I'd love to see how these topics could converge in the future. So as a background, the kind of production product that we're doing right now is in iOS 15 and macOS Monterey, which are the current betas. We have a new feature called iCloud Private Relay, and it's a user privacy feature that's trying to separate out client IPs from origin servers, and it's based on 2 fundamental technologies. One is mask proxies, which are quick HTTP3 based proxies, and we have a multi-hop network of these to make sure all the data is separated. Think like a mini Tor-like thing. And then we're also using oblivious DNS over HTTPS for all other traffic that's not fully proxied. Okay, so why is this here? Like, why is a privacy proxy relevant for path-aware networking? And I think it actually is pretty relevant, because if you look at the architecture that we're working with, you have kind of maps that look like this, in which you, when you're trying to get to any particular destination, we now have a lot more choices that the client can make. And this is true for Tor and stuff today. But with these mask proxies, we actually have a lot of different ways we can choose to route traffic along different nodes and combine them and figure out many, many different paths through this. And this is something in the architecture that we have that the client is in control of and has awareness of, mainly as a privacy thing, but it also opens up a lot of path-aware properties in general. So there are some privacy benefits that we get from having path awareness and path control. So the clients can learn about a diverse set of different proxy hops and try to route their traffic in a way that makes it less likely that they're going to be tracked. They have control over which hops are used, and this where things are going, where you're actually routing on your path, because these are secure, quick handshaked proxies, you're validating the identity of every node along the path. So you're really sure where you're going. And it's separating the data out of who can see your IP address versus who can see where you're going, and that improves privacy. And you're also able to switch paths periodically and rotate them to make sure that you're not sending all of your data to one spot so they can collect a lot of information about you. So those are good privacy benefits. But then there's also a lot of good performance benefits, and that's, I think, some of the things that we normally would talk about in this group. You have the fact that I can select an egress proxy, so the thing that I'm going out of, to be very optimally co-located with the content. Right now, the things that are hosting these proxies for us are some of the biggest CDNs in the world, and so we're able to get right to their content while also doing this privacy preserving mechanism. And the clients also have the ability to switch over and fail over between different paths as they realize that maybe one is broken or there's a better performance on another path. They can choose to switch and do measurements on these. Also, because this is using Quick supports migration, and so there are avenues that we have still yet to fully explore about what it means to do migration across different paths. So you can have like your final egress proxy be stable, but end up trying migrating that connection over many other different intermediate proxies and see which combination ends up working best. One of the things that we've also been trying to make sure of here is that by using a proxy, you don't have to have the thing that people often think about as like, oh, VPNs and Tor is going to be slow. Proxy connections are actually really great because you can kind of always fast open on them. There's a thing that we're working on in Mask to make the proxy quick aware, so it's able to forward packets without any re-encapsulation and be very, very efficient. And so in a way, you can think of these proxies as really just authenticated and validated NATs or routers that you can essentially prove which NATs or routers you're putting information through. But other than that, they're really just forwarding encrypted packets up and down the stream. And then, this right now is something that we're doing as a particular deployment of a product, but we'd like to see it kind of expand in use case. There's new work that can be done on how do you discover new proxies and new paths you can take. How can you discover which hosts have better affinity towards specific content that you can reach? And I think there are a lot of really interesting research topics that we could do around how do you migrate traffic efficiently and split different connections on different paths through proxies to optimize traffic. And then you're kind of looking forward, if we see things like mass proxies become more ubiquitous, and I know there are proposals for them to be used for different 3GPP technologies, you could imagine, ingress proxies being hosted in all ISPs and carriers, having specialized ones for zero rating and different paths that they can take, different purposes. Egress proxies essentially hosted by content. And so we're allowed then to have really, really good privacy, but also have really cool properties about path selection. Anyway, so this is just a topic I wanted to introduce to this group and get people's thoughts on. We are out of time, I know, but I'd love to hear what people think, and we can talk about it on the mailing list too, or in the chat.
Thank you very much, Tony. This is really exciting, actually. So we have, strictly speaking, 1 minute for the session time, but yeah, if people are willing to stay a little bit longer, I don't know. So Spencer.
Tommy, are you going to be in Gather after this? And now I'll hang up.
Yeah, good point. Good point. Huh?
Yeah, I can. I can be
Everyone went together. Okay.
Yeah, we can do that.
Okay. In this case, this concludes the session. Thank you very much, everyone. I think we'll need to schedule a longer session next time. So see you in the next IETF. Thank you very much, especially for those who was taking meeting minutes and was looking at the Jabber. Thank you very much. Okay.